Hey guys, welcome back. So this is what the shelf tool made, and let's take a look at what it actually did. I'm going to hide this and let's type in geometry. I'm going to create a grid and I'm going to give it a size of 500 by 500 and 1000 by 1000. Cool. So this is our grid. We need enough resolution to display the ocean. And if we type in ocean, if we hit tab and type in ocean, these are the nodes that are related to the ocean. The two main one that we're going to use or related to our workflow is the ocean evaluate and the ocean spectrum. So let's create ocean evaluate. And what we need to feed this is the geometry. And then the second input is the ocean spectrum, and this is what defines the waves itself. So let's create an ocean spectrum node, which is a separate node, and this is where we get to define the ocean, the wave type. Now, if we do this, you can see already the tiling problem. Okay, you can see this is going to happen. So we need to fix that. We need to break this up. And what I'm going to do is I'm going to set the ocean spectrum here, and I'm going to go over the settings quickly. So the grid size is we want to define how big our grid is with the geometry that we're going to use for the render. This also relates to the scale. So in this example, we're going to match the geometry preview that we have, and then we're going to call this large spectrum. And our my idea and Igor's idea is to create multiple ocean spectrums and overlay them on top of each other. So I'm going to set the resolution. I'm going to increase the resolution so we get nicer details here. Let's increase this to 9. And then the wave instancing, this doesn't work. This doesn't have any effect. And then the depth, we're going to leave all this to the default. The seed is very helpful to get random patterns if we want to change. We want to keep the same type, but we want to create another variation. The seed is very, very helpful. And then we have a time scale if we want to change how fast the ocean moves. And then the main section, the main part for controlling it is the speed. And I'm going to increase the speed, and the idea for this main wave is to get big waves, the main layers that move the entire ocean. And then on top of this, we're going to have mid waves and then another layer for small waves or fine details. And I'm going to set the directional bias to 4 because I want more variation between the waves. And let me disable this floating, this origin thing. Okay. And let's increase the directional movement. Let's increase the choppiness, and this is going to control the peak of the waves. We can increase this, and you will see it peaking more. Yeah, that's too much. Let's try 2. You can see the peaks are sharper now. Let's set it to 0.8. And with this one, we don't need a lot of resolution. We don't need a lot of details. We just want the main movements, the bulky movements. And under the amplitude, the only thing I'm going to do here is this min wave length is very, very important, because what we don't want to see in this layer is the small waves. I'm going to set this to 0.05, and you can see already smoothed out all the fine details, because we don't want those in this layer. We just want the main movement. So let's reduce this to 8, so it's faster to evaluate. And if we hit play, you can see we're getting these big waves. And this at this scale, this is actually enough deformation. We don't want to go higher, because if we go higher, then we're going to be talking about stormy ocean. I want to keep this this height for now. Now, to break this up, let me tile this. Let me copy this geometry. So let's make, I'm gonna reduce the size here, the resolution, and let's set this to 500. So that's a copy. Let's set this to 4. And let's do 2 and 2, and then here I'm going to set it to 500 on the Z, and now we have 4 tiles, 4 blocks. And with what we're doing now is we're tiling the large maps, the large map, and the more we do this, the more repetition we're gonna get, and we don't want that. We want to fix that, and the best way, or we need a way where we are able to do this with any render or with Redshift primarily. So what we're going to do is I'm going to copy the spectrum, this large spectrum node, and I'm going to simply change the seed to 70 or something, some number. Okay, now if we, let me copy this. Now if we look at the 2, you see there's a variation. Now what I want to do is I'm going to create a point VOP. And I'm gonna go to the grid. I'm gonna create a noise pattern based on the position, and let's connect that to the color, and let's increase the map so it's very, reduce the noise frequency, something like that. And I don't need any roughness, I just need big blocks. And I'm gonna copy this and paste relative reference here. And this noise right now is has negative values, so I'm gonna clamp it between -1 and 1. Sorry, between 0 and 1. And we have a map now. We have a noise pattern. So let's change this. You see now we have a noise. And what we can do is we can use this noise information to mix between various maps. So let's bind export this as large or ocean big or large. Let's match the name. And I'm gonna bind export this pardon me, as pardon me, as an attribute. Okay. So if I do the ocean evaluate, I have that attribute transferred, and I have it here as well. So if I middle click, I have that ocean large. I'm going to create another point VOP. I'm going to connect this and connect this node. And I'm going to import the point position from the second input. So import point attribute. And I want to import the point position from the second input, and then I want to mix between them. So I'm going to mix between this, and let's plug that into the CD, and let's change this value. You can see how the map is changing. Sorry, I'm going to do one thing here. I want to set the gamma to 1 in the viewport. So you can see how the map is changing. And instead of using this 0 to 1 driver, I'm going to bind import that ocean large mask, and I'm going to use that as the driver. Now the noise value itself doesn't reach 1. So if we take a look at the noise in the spreadsheet, see here it's 0, and then the highest value is 0.18. So I want that to be 1. And what I'm going to do is I'm going to multiply this by 5. And with the clamp, we're going to be certain that it's going to reach 1 or stop at 1. So 5 is not enough. Let's set 7. Okay, so we have 1 and then zeros. So let's take a look now. This is the original. This is the other map, the offsetted one, and this is the mix. And you can see now we're getting a very nice breakup. And this is really easy to control. If we want different patterns or different variation, all we have to do is control this noise. So I can increase the frequency, I can change the offset, I can do whatever I want to get interesting mixers. And if we run this now here, it's gonna work much better with the noise. Now our noise is copied here, and we don't want that. We want the noise to be generated on the full grid. So instead of passing this large instead of passing this geometry and then copying it, the best way is to multiply this, let's say by 2, and this by 2, and now our noise map is going to have the correct value, and this is going to cover more space. And if we go and look at it, let's turn this off, it's going to be perfect. So this is not what we're going to do to visualize this. And that's it. That's how we're gonna mix the maps. Now this is the large layer, and this is what I'm going to use. And in the next video, I'm gonna show we're gonna create the mid and the small layer maps, and then we'll continue and see how we're gonna do the same thing in Redshift. Thank you guys for watching, and see you in a bit.